So I wanted to make a quick video going over my research and the problems I encountered while building my first NAS, just in case anyone stumbles across this and wants to follow what I did or may have run across similar problems. They can see what I did. So I went with TrueNAS, and TrueNAS uses ZFS, and this is important to picking out your hardware because ZFS does certain things that other RAID software does not, and it has certain advantages and disadvantages. And I just have a little chat GPT up here talking about the differences, but it has some advantages like self-healing, snapshots, resilience to hardware failures, and during my research it seemed like one of the better options because I have lots of photos that are irreplaceable. So it's not just a media server like some people, but it has a lot of data that I don't want to lose, so I went with the RAID Z2 configuration. And so when you choose TrueNAS, you can choose between core and scale, and really the main difference is core is built on a base operating system called FreeBSD. That's quite a bit older, and a lot of people consider core to be very, very stable. But from what I read and what I heard is that the support for core is kind of going down because people are losing interest in FreeBSD. And so now what's new and what everyone is using, especially in the last year or two, is Scale, and Scale is built on Linux. And if you're familiar with Linux, the user structure, especially permissions, command line, all these things will be familiar. It also supports Docker containers. You can run apps inside TrueNAS, which is nice. So when choosing hardware for TrueNAS, there's a few things you have to keep in mind. We can start on the hard drives. So basically what I found is you want something called CMR hard drives. So that's conventional magnetic recording, and you can quickly pause here and read the difference between CMR and SMR. But basically TrueNAS does a lot of reading and writing, a lot of writing really to check the data integrity, and just the way that the SMR drives, they overlap the data so they can pack more in on a cheaper drive. It's not as robust as CMR, so everyone recommends CMR drives for TrueNAS. They're a little more expensive, and they are a little harder to find. Sometimes you have to really look at the data sheets and things to find out if a certain drive you're looking at is CMR. And so I ended up going with these Seagate Exos drives, and these are enterprise drives. I got them used from an eBay store, this Go Hard drive. A lot of people also recommended using a website called Server Parts Deals to find these refurbished drives. If you look for refurbished or used drives, you just want to make sure that they have no bad sectors and the smart data is good on them. And I can let you look into that more on your own. But basically, it sounded like just go with CMR, go with NAS rated drives or enterprise rated drives. And so these specify right here, built on 10th gen conventional magnetic recording technology. So there you go. The next thing to consider with TrueNAS is it uses RAM cache. So basically your frequently accessed files are stored in memory, and the more memory you have, the better your performance is. So while some NASs, like Synology NASs I've seen, they only have like 4 gigabytes or so of memory, you want a lot more than that on a TrueNAS or ZFS setup. And they recommend about 1 gigabyte memory per terabyte of storage. So because it's cycling all this data through the memory constantly, and it's performing these checksums on the memory, you want to, what everyone recommends, it's not necessary, especially for a more casual user, you could say, but it doesn't cost a whole lot more if you're smart about it and you can find some good deals, which I'm going to show you how I did, is to get error correcting memory. Error correcting memory basically accounts for single bit errors, and that's things like bit flips from cosmic radiation is kind of the famous example. And when you're looking at error correcting memory, there's 2 types. There's UDIMMs, there's unregistered or unbuffered, and then there's registered. And when you're looking on eBay and scrolling through all the listings, you can quickly tell generally between normal memory, unbuffered memory, and registered memory. So a normal RAM stick would look something like this, where you have 1, 2, 3, 4, 5, 6, 7, 8, or an even number of memory chips. ECC memory will always have 1, 2, 3, 4, 5 on this side, 6, 7, 8, 9. So it'll have an odd number of memory chips. So in this case, this one has 9 memory chips. And then it'll also have UDIMM in the name. So you want to look for UDIMM ECC memory as your kind of keywords searching. RDIMMs, they work on more of the real server hardware, and these use a register, and you can kind of pick them out quickly because it'll have this register chip in the center most of the time, and you can see those. So the motherboards we're going to be looking at today don't use register RAM, but you can find them. But they tend to be for more of the full-size Xeon systems. So we found our CMR drives, we found our UDIMM ECC memory, and now one of the trickiest parts I had to go through was finding an appropriate motherboard that supported ECC memory. Now, if you do a quick search, you'll find that I think it's ASRock boards. ASRock motherboards supposedly support ECC memory with AM4, like AMD AM4 systems, and AM5 I think as well. Now, everything I looked at was people were going back and forth on it, whether it really worked or not. You know, you could put an ECC memory stick in there and it would work, but you'd kind of have to do maybe some manual tests using memory testing software and introduce errors to see if it's actually correcting the errors or if it's just accepts the memory stick but actually doesn't do the error correcting. So I decided to go for more of a reliable solution, something that's not consumer hardware. So what always came up in the TrueNAS forums was these super micro motherboards. So these are enterprise motherboards. They make workstations, servers, all sorts of stuff. But these high-end components, they're super stable, they're high quality, and they have a lot of options, which I spent a long time looking through. And what I kind of landed on is that if you're running a NAS, you're also likely running a Plex or a Jellyfin server, and you may want to run that on the server itself. And hardware transcoding becomes important in that case. So hardware transcoding is basically if your client, like if someone's watching on a TV or a phone or a computer, and the file that you're serving to them can't natively play back that file type, the server will transcode the file into a file format that the client can understand, that the client can play back. And the best way to do this is either to use a separate GPU or to use a CPU with integrated graphics. And Intel has something called QuickSync, and it's a very efficient way of transcoding. And different generations of processors have different transcoding support. So the minimum you want to go for is 6th gen. And from what I understand, 8th gen or higher is the best. But I ended up going with 7th gen due to cost of the motherboards, and we'll get into that. But you can go to this page here on Intel's website, and they show you all the different media codecs supported by the different generations of processors, which is really helpful in deciding what you want to do. But I was primarily focused on finding a really good system, really stable system that's powerful enough that doesn't break the bank. And for me, I found that going from 7th gen to 8th gen was pretty much a double in price on the motherboard, a double or triple in price. So when you go through and look at all these motherboards, there's tons and tons and tons of models. And what you want to do, what I focused on is I focused on 6th and 7th and 8th and 9th gen motherboards. So I think they all use the same socket, but due to different microcode, 6th and 7th gen motherboards, motherboards that support 6th and 7th gen CPUs are not compatible with 8th and 9th gen CPUs, and likewise. So you have to decide what CPU you want. And so you can go to the Supermicro website and go to their motherboards. And what you want to do is filter by chipset down here. And I've filtered by Intel C232, 236, 242, and 246. And I'll bring up a little chart I made of the main differences between these. And so with 232, it supports 6th and 7th gen, and you can use the little Xeons. They're not the big Xeons, the true ones, but they're kind of just like a desktop processor that's called Xeon. Or you can use an i3 or like a Pentium or Celeron or whatever, but you want to go with an i3. And the reason you go with an i3 is because it has the built-in GPU for transcoding. You don't want a Xeon, unless you don't need transcoding and you want a little more power out of it because it has more cores. And then the difference between the 232 and the 236, and the same with the 242 and the 246, is the number of onboard SATA ports. So you can go from 6 up to 8 for each of those. If you want more than that, you'd want to go with an HBA card, an HBA PCIe card, and flashed in IT mode, which you can buy. They're already flashed like that. And then you can expand to more SATA ports, or you can use SAS drives. But I didn't get into that for this build. I want to just keep it a little simpler, save a little more money. And so when you're looking at all these motherboards, you want to look at a few things. First thing I always looked for was, does the motherboard have IPMI or BMC? And IPMI is it's a built-in chip and a kind of a really basic GPU that sits at the motherboard level. It manages the motherboard. So you don't need a CPU or memory or anything installed on the motherboard to access the IPMI. It has its own Ethernet port and web interface. And you can log into this and access the BIOS. You can install operating systems. You can update the BIOS and do all sorts of things without even having physical access to the motherboard. So you could be in a different country and VPN into your server, into your home network, and then log into the motherboard, and you can reinstall the TrueNAS operating system from another location if you really need to. Another thing is M2 slot. Some of these older boards, these 232 and 236 boards, most of them don't have an M2 slot for like a boot drive. So I ended up going with something, let's see, something like this, just a little PCIe adapter for an M2 drive, which is not a big deal. But I'll show you what I needed to do to get that to work on this specific implementation. So M2 slot, PCIe slots and lanes. You may want a certain number of PCIe slots if you want a dedicated GPU for transcoding, or if you want a 10 gigabit Ethernet card or whatnot. Another thing is onboard NICs. Most of these motherboards come with two 1 gigabit ports, and they have Intel chipsets. They're high quality ports. Some of them come with 10 gigabit ports as well. Those are going to be a lot harder to find than the standard, and a lot more expensive. But personally, for something like this, I would just go with the basic gigabit ports. And if you want 10 gig, just go with a 10 gig card with SFP plus and do like a direct attach cable or fiber or something instead of 10 gig over copper. And then SATA ports up here, which we looked at. So we can look at some of these. So the board I ended up going with was the X11 SSL -F here. And so this supports 6th and 7th gen Intel Core i3, as well as the Xeon V6 and V5. It's a 232 chipset, so I get 6 SATA ports. And it has a good number of PCI ports, PCIe slots here. One thing to look out for is that they are limited. So it's a PCI by 8, but it's in a 16 slot. And this one's a PCI by 4, but it's in a by 8 slot down here. And this one has the IPMI, and you can see here it's the A speed, and you can tell just by looking at the board as well. It will have this A speed chip up here, and that's your IPMI chip in the miniature graphics chip, basically. So I went ahead and I ordered this board, and I also ordered a 7th gen Intel i3, and you can see the prices I paid for all these things. And these CPUs, they're getting so cheap now. It was only $10 on eBay. So I ordered that, and I had some problems. First was I was having a hard time booting, and what I realized later is that my BIOS version was too old. So you'll notice here it says BIOS 2.0 or above required to support 7th gen i3. So this ended up being kind of a process to learn, to know how to figure out how to do this. These server motherboards, they don't have some of the modern conveniences of updating the BIOS. So they're doing it manually at least. But if you can do it over the IPMI, it's really helpful. So when I got my board, the IPMI and the BIOS, they're two different sets of firmware. They were dated at 2015. So definitely not the BIOS 2.0. And so we will look at the IPMI here. So you see I just go to the IP address of the IPMI. It's a separate LAN port. And now I can see I've updated my firmware at this point. So my firmware for the IPMI is dated 2024, and the BIOS is dated 2024 as well. And so if you're able to log in, what you can do is go to your maintenance and firmware update, and you enter update mode. And if I remember right, all I had to do was basically load in a file directly from this interface here, from their downloads page here. So I went to resources on the motherboard, and then I found it's called the BMC firmware here. And you download this, it gives you the BIOS, and it gives you the BMC, which is also the IPMI. And so that was the first step. And then what I needed to do is you can't really get you can't update the BIOS from IPMI. You have to do it manually using command line, unless you have the license key for the IPMI. So this was quite interesting, actually. I found this website here, and you can generate a license key for your motherboard. And so you go to this website here, and this guy actually he shows how he did it. Actually, it's very clever how he did it. He's way smarter than me in this type of thing. But he basically extracted the firmware, looked at the binaries, and reverse engineered, I guess, the process of how they generate the license key. And so you can use this. You can use this to find your license key. You put in the MAC address of the board. And so if we go here, I can't remember exactly where you put in the license key. But when you update the IPMI and you get the license key, another thing you get is the HTML5 KVM. So the KVM is it's like your remote control. So I can KVM into my TrueNAS. So this is the same as if I was plugging in a monitor into my TrueNAS system right here. And you can basically watch it boot, you can enter BIOS, do all these things from this KVM here. But previously how I had to do that was use this old Java method, and I tried to figure it out on my own, but I couldn't, so I ended up having to download this IPMI view tool, which kind of installs all the required Java for you. And you can enter the old Java KVM, but it's a pain, and you have to have it downloaded. With HTML5, it's a lot easier. It's just in the web browser. So then you have your IPMI updated, and you have your license key. At that point, you can just update your, oh, there's the activate license right there under miscellaneous. So at that point, you can go in your maintenance and update the BIOS, and you can just pull it from the file you downloaded from the resources here. So that's what I needed to do for that. And then at that point, I was ready to boot up TrueNAS. So I downloaded the ISO, and I flashed it on my hard thumb drive, and I put it in there, but it was not detecting it as a boot device. And it turned out this was another thing I needed with the updated BIOS. I can't pull it up here, and I'm not going to reboot the server, but this ended up being really important. Is I need to go into the BIOS, and under the PCIe settings, there's a setting for the driver or the firmware of the PCIe device, and I needed to change it to I think it was called the native firmware, or the something like that. But it was a setting for the PCIe driver or firmware that was not present in the old version of the BIOS. And I found this out from looking. I spent like an hour or two looking at it on the forums and everything, and one guy mentioned, oh, I finally got it working. I had to change this setting in the BIOS, and I was going through my BIOS and I didn't see the setting, and that's kind of when I knew I needed to update the BIOS, and that was to boot from my NVMe drive on my PCIe slot. Now, if you're booting from a SATA port, you wouldn't have a problem with this, I don't think. So then at that point, I installed my TrueNAS, and here it is. And it's been working good. I have 6 drives, and I'm doing RAID Z2. And so we can look at the total price of everything. So I ended up finding my motherboard for about $80. I got some RAM here, the processor. I found this power supply local. It's really cheap. Got some SATA cables, 2U chassis, some screws, and then 7 hard drives. I got 7 hard drives because I'm using one as a cold spare. So if one goes out, I can quickly replace it without needing to wait for a new one to get shipped. So yeah, we can look at the X11 SSL-F on eBay here. So it's kind of random, it seems, on some of these boards what the prices are. And I looked for a long time, and some of the higher tier ones, the ones that support the 8th and 9th gen processors, they were all almost around this $250 mark. But I found this one is kind of in a sweet spot. I don't know why it's so much cheaper than others, and even others in its same generation, it seems to be way cheaper. But you can find some good deals. Like this one here is a great deal. This is even better than what I got, because this one has, so mine had the Xeon and it had the heatsink here, but this one comes with memory as well, which that's actually a great deal. $80 plus $13 in shipping. And I found that the included heatsink here, this low profile server heatsink, was totally fine even with very low fan speed. The CPU never gets above 40. At idle it sits at 20. It really just sits there. It doesn't do much at all. You don't need much CPU power for these systems. So yeah, that's about it. I'll put links to some of these resources on how to set this up, and I will also show you what my server looks like here. So this is pretty rudimentary at the moment, but there's my board, my chassis, my power supply, the hard drive bays here. These are pretty basic, but they work because this is all about saving money. And this is the IPMI port here. It's the one above the USB ports, and then here's your two LAN ports there. And then here's my server in the completed in my new little rack I built, and yeah, it's been working great. But it was quite a process. You can obviously go with a pre-built like a Synology, but these are crazy expensive for really the hardware you get. I'm not sure where the okay, so yeah, we can look at this one. This is a 4-bay, 4 gigabytes of RAM, and it's $680 just for the NAS, and it's a 4-bay. Where with my system, I was able to get the entire system with 6 drives plus a spare for just over $700. And I think it's a pretty good balance of saving money and reliability and performance and, you know, robustness. So I hope that helps with anyone looking to find hardware to build a NAS, or if you get stuck on certain things, setting it up. Setting up the motherboard definitely took me a couple days of research, because server motherboards they're quite different than consumer motherboards. So it was a little harder, but it ended up working out at the end. So yeah, thank you.